Welcome to the short answer feedback for week 7 homework, respiratory system, structure, lung volumes and air. So let's have a look at this first question. The graphs in figures 7 and 8 show the runner's depth and rate of breathing at rest and during exercise. So just to make it clear, we're going to underline at rest and we're going to underline during exercise. So we know that there is a difference between the two graphs. So moving to the first question, it says identify using the data in figure 7 the name of the lung volume labelled A. So I've bugged my command word, I've highlighted my keyword that we're looking at this graph here, figure 7, and we're looking at the lung volume A. So I've circled A to make sure that I'm clear. And this is worth 1 mark. So we know there are 2 different lung volumes that we can measure. We have tidal volume and we have vital capacity. The answer to this question is tidal volume. And we can see that we often think about the tide coming in and out. So we've got that in, out. So the amount of air we breathe in and out, or inspire or expire with each normal breath or during exercise. Our other volume would be vital capacity. Right, next part of the question. It then says explain 2 reasons why figure 8, so this time we're focusing on this graph here, represents the runner's breathing rate during exercise. So if we have a look at this graph, we're comparing this now, this is during exercise, and we're comparing it to this at rest. So 2 possible responses, and you could have had them in either order. So the first response is that figure 8 shows an increase in breathing rate. This is because the lines on the graph are closer together. So if we go back to these 2 graphs, in terms of breathing rate, we've got 1, 2, 3, 4, about 5 breaths in 30 seconds. On this one here, I've got 1, 2, 3, 4, 5, 6, 7, moving on to the 8th breath in 30 seconds. So the lines here, this distance, they are closer together. So that would be our first response. Second response is the fact that in figure 8, there's an increased depth of breathing, or you could use the word tidal volume. This is because the lines on the graph are longer, and we could use the data on the graph, so e.g. from 0.5 to 2. So if we go back to our graph, we can clearly see that the length of line here is much smaller compared to the length of line here. This is about our depth of breathing. And those figures, the 0.5 and the 2, they have come from the data on the graph. Okay, let's turn over. So, question 6. We have a pie chart. And we've got 2 pie charts that are comparing inhaled air and exhaled air. So figures 5 and 6 show the percentages of oxygen, carbon dioxide and nitrogen in inhaled and exhaled air by a long distance runner. And our question states, analyse using the data in figure 5 and 6, the difference between the runner's inhaled and exhaled air. And this question is worth 2 marks. What they're looking for is 1 statement about the difference of oxygen, inhaled and exhaled, and 1 statement about carbon dioxide, inhaled and exhaled. So if we look at possible statements you could have given first for oxygen, you could have said there is more oxygen in inhaled than exhaled air. You could have said that oxygen levels decrease when exhaling, which is true when you look at the data. Or you could have said that you breathe in 21% oxygen and you breathe out 16%. Again, those figures are taken from the data above. In terms of carbon dioxide, you could have said there's more carbon dioxide exhaled than inhaled. And when you look at the figures, that is true. Carbon dioxide levels increase when exhaling. Again, we can see that from the figure. And we breathe out 4% and we inhale 0.04% carbon dioxide. So in order to get your 2 marks, you needed one statement from here and one statement from there. Okay, final question. Explain why there is a difference in the amount of oxygen and carbon dioxide in inhaled and exhaled air whilst the long distance runner is training. So we've continuing with this long distance runner, and this is worth 4 marks. So we've got 2 marks available for talking about oxygen, and we've got 2 marks available for talking about carbon dioxide relating to the long distance runner. So if we look at oxygen first, okay. Whilst the long distance runner is training, more oxygen is required or needed. Therefore, oxygen can be used in aerobic respiration to release energy. So we know that glucose plus oxygen equals energy, and that's why there is more oxygen needed. If we then go with the carbon dioxide, more carbon dioxide is exhaled by the runner, so that's a difference, as it is a waste product produced in aerobic respiration in the working muscles. And again, this is true to our equation. Glucose plus oxygen equals energy plus carbon dioxide and water.